Okay, so back to where we were, Chapter 5, Homework 5.5, right? It's a written assignment?
Yes.
Okay, cool. So, as we were talking just a little bit ago, so it's going to be a square or a rectangle with two quarter circles that you could subtract. You could also add the quarter circles together to make your half circle, like Dr. Jackson was saying. Um,
Mm-hmm.
and that would kind of simplify it, but you don't really have to. You can do two quarter circles like what I did. It doesn't really matter. So I chose the quarter circle pattern. So, like he kind of explained when he did some of the example problems, break them into pieces, like 1, 2, and 3, or how many pieces that you see in the diagram.
Mm-hmm.
So I just did the rectangle and then minus the two quarter circles because they are taking away from the rectangle. Does that make sense to you, right?
Yes.
Cool. Okay, so um, you'll have to reference your book for the equations to find your x bars, y bars, and your areas for each shape. So
Mm-hmm.
he'll give you that in the exam, so don't worry about trying to memorize them or nothing.
Okay.
So what I did was um, I first found the areas of the three shapes, so area of the rectangle, quarter circles, and I did some of the work down here. So I just labeled it A1, A2, A3. The two quarter circles are going to be the same because they're exact same size and you have the same radius. So I get 96 square inches for the rectangle and 12.566 square inches for the semicircles. Um,
Okay.
this part to the right that I labeled as number 2, that is me finding the x bar of one of the quarter circles because they're on the same side. You can do it for one and you consider it for both. That's kind of like the
Okay.
nice part of it. So the equation that I'm using right here is the equation from the book, which is going to be x minus 4r over 3 pi. The
Mm-hmm.
x just means your full distance x from one end to the other, or to the center. But this one would have to be to the full length because, let me get my highlighter out so you can see it. It needs to be from here to the end because the end right here is where the center of the full circle would end up being. So that's why we're using that as an x.
Okay.
So after doing that, you create your table using your x bar, y bar, sum of forces in the A, x bar times A, everything like that. So the nice thing about this problem is that if you look at it, it's symmetric because of the two circles on one end. It's
Mm-hmm.
symmetric. So that means our y bar is gonna be in the center regardless of what we end up doing for the math. If you do the math, it's gonna come out to like 5.98 or something close to that. So we just go ahead and round it to 6 because of that. It's half of this total length from O to Y.
Right.
So because they're symmetric, we can just go ahead and ignore or kind of neglect the y distance for doing that in the math portion. You can just say due to symmetry, it's here. And you can do that for most problems too. If it's symmetric, you can overlook some of the math and make it simpler for you.
Okay.
So in doing that, you find your x bar of 1, which is a rectangle, which was 4 inches, which is half of that distance of the 8. I went ahead and did the y bars anyway, just because I was doing the math and I just wanted to make sure I was doing it correctly. So the y
Mm-hmm.
was 6 inches for the rectangle. Now if you look at the equation in the book for a semicircle's y, it is the y distance minus 4r over 3 pi. But since the y, due to symmetry, was 6 inches, I went ahead and marked them out when I was doing the math, just because I knew symmetry and I can just go over it.
Mm-hmm.
On the x portion for the semicircles, I wrote the equation right here, but I didn't do the full math. That's because I did it over here.
Okay.
I just knew where that my value was, and I plugged it in later on for the math.
Mm-hmm.
So then, also finishing out the table, we need to find our x bar times our area of each line. So this would be 96 square inches times 4 inches, which this actually will be coming into cubic inches when you do keep your units. It's good to keep the units like that because when you end up solving for large x bar, when you're going to be dividing by, I think another square inches, and so you'll end up coming down to just 1 inch, and that will be what you need. So keep the units with it. It will help you
Mm-hmm.
kind of keep straight on it. So following suit, I went ahead and did the y bar times the a's, just for just nomenclature. I just kind of had to do it um, to keep myself straight on the problem, but you don't really have to since we already said it's going to be due to symmetry. So
Right.
after that, you find your areas of the semicircles, which they're both the same, but keep in mind that they're negative because they are taking away from the rectangle, so they are subtracting.
Okay.
That can catch a lot of people off guard, so just always watch for they're kind of like considered holes, or it's just taking away from the main material. So after getting the
Mm-hmm.
table set up, you go ahead and find your sum of your areas. I just found the total sum of the areas, which is right here. I went ahead and found the total sum of my x bars, which is here, 16.605. And then I went ahead and did some of the math to make it easier for me. I did some of the x bars times a, so that means all of this right here, which is 225.6 cubic inches. After finding those, you can use the equation that it's stated in the notes or in the book, whatever. So it'd be large x bar times the sum of the areas is equal to smaller x bar times the area. So the sum of the areas was 70.868 square inches, and our x bar times a, which is the sum of x bar times a, which was 225.6 cubic inches. Solving for large x bar, we get the global centroid for x bar to be 3.18 inches, and due to symmetry, we can say that y bar is 6 inches.
Okay.
And that's pretty much all you need to know for this problem. Do you have any questions? I'll kind of zoom out so you can kind of see the entire problem. There we go.
Mm. Mm.
Now, if you wanted it to do in the half circle way, like Jackson would have done, all you would have had to do is just add these two x bars and areas and everything together,
Oh, okay.
and then you would have been able to still be able to do the same math, which is kind of what you end up doing towards down the line using the semicircle, the quarter circles. You end up adding them together, which in this case these two are added together plus that. So the math in it works out. So you could do it different ways.
Okay.
Jackson combined the two just because it was less work for him. Instead of doing three, he only had to do two.
Right.
But to keep myself
Okay.
straight, I went ahead and kept them separate. Now,
Okay.
if this would not have been symmetric, say if one of these circles was in the center and not on one of the ends, or somewhere symmetrically placed, I guess you could say. Like if the one of the circles was on the opposite side, it'd still be symmetric. But if we had one right here like this right now, and we took number two, and we said we put it in the dead center, that would be
Mm-hmm.
different. Then we'd have to worry about our y bar.
Oh, okay. I see.
But that one's pretty much it. Did that kind of clear it up at all?
Yeah, yeah, I did. Thank you.
Yeah, no problem. And just keep in mind, like, this equation right here is how you find x bars, the large x bar and everything. And I wrote it, when I wrote it, it's kind of hard to see, but it's a large x bar minus little x, or equal to little x bar.
Oh, okay.
Yeah, because the capital X means global, little x means local.
Okay. Yeah.
Yeah.
Okay.
And then if you want to do the y, you do the same thing, you just plug in y instead of x.
Mm-hmm.
But yeah.
Okay.
Any other questions?
No, I think that was pretty much it. Thank you.
Yeah, man, no problem.
All right.